Hello everyone, welcome back. Today we have 2610 convert an array into a 2D array with conditions. It says here you're given an integer array nums, and from here we are to create a 2D array from nums satisfying the following conditions. So the 2D array should contain only the elements of the array nums, so we only use the nums provided, and each row in the 2D array contains distinct integers. So if it's an array of arrays, each subarray should contain all distinct elements within that subarray. And the number of rows in the 2D array should be minimal. So whatever all we're doing, we want to optimize it to use as few subarrays as possible. So the easiest thing, of course, would be, sending every element to its own subarray, but then we're not optimizing, and we want to optimize for as minimal subarrays within results. And then finally, we return the resulting array, and if there are multiple answers, return any one of them. Okay, so we're given this input, so these are our nums. Now, the most intuitive way is an n squared solution. So let's run through that. And that's basically going through each number, checking if that number is already in one of these subarrays, and if not, we can insert it. And if we exhaust all the subarrays, then we create a new subarray and insert it into that. And so that we can have a O of 1 lookup type, we can use C. So this result will be a list of subarrays, an array of subarrays, and scene will be a list of sets or an array of sets. Okay, so let's start iterating each number. We start on the first one. Now, we don't have any sublist to check at this moment, so we need to create one. Okay, and actually, let's create one down here first. So we check scene. One is not anywhere. In fact, there's nothing in scene. So let's add 1. Okay, so we have 1, let's say. And then once we add it to scene, we can add it to result. Okay, now we're done with this guy. The second one is 3, 3. Now we do have one list in scene. 3 is not in that list, so we can add it there. Great. And then we can also add it to result. Great. And then we move on. We're on 4. 4 is not yet seen in this one, so let's add it. And I haven't made this clear, but this is a set, not a list. Okay? And then make sure to add it here. Now we reach a point where the next number is actually already seen in the current subset. So that's okay. We can move this one. Let's actually move this guy a little bit to the right. Okay. And then this guy also, let's move it a little bit to the right. And then we can move it to the new set. So 1 can go in its own. Because it duplicates this guy, we can't add it to this set. Then likewise, we can add it over here, and we're done. Now 2, when we iterate this, it's not in the first set, so we can immediately add it to this one, and the corresponding end results list, and we're done. 3 is already here. 3 is not here. We can add it here. Okay, and then add it to here. Okay, and then finally we're at 1. 1 is duplicated in both places, so we add a new set. Okay, and then we add it to the result here. And we're done. And that's basically what we get. So this is the first way. This is the most intuitive way. But it is O of n squared, right? And the space is linear because we are using all these lists and sets. All right, so let's quickly run through that. So what we did here was we had some result, which would be a list of lists, and then we were tracking the ones that are seen. So this is a list of sets. This is a list of lists. And we said for every num in nums, we're going to keep track of whether or not we were able to successfully place it within the existing scenes. And so we can say for nth in range of length of either scene or result, same, we're going to say if the number is not already in scene of that nth scene set, then we can add it to this number, and we can add it to the corresponding result subarray, this number. So this is a set, so we're using add. This is a list, so we're using append. And since we were able to successfully place it, we can say place is now true, and we break. So when we break, we end up breaking out of this for loop, and place is true. Now, if we are not able to place it, so if not place, all we do is append a new set into scene. So scene dot append, because scene is a list and inside is set. We can append the num as a set. So this is squirrely bracket, curly brackets. Okay, and then we can also append into results a list of that number. And at the end, we can return results. So this is the most intuitive way. Let's run that quickly and make sure that works. And it does work. And now there is a more optimal way, which we can do in reverse order. We can go through the code and then run through why it works. But this is basically saying, okay, you know what? Let's first get the counts. So from collections, import counter. This is not required. Leetcode already has it, but in case you're wondering where counter comes from, it is from collections. And we can say, okay, first let me get the counts. The counts of the frequency of each number in nums. And we can do that easily by sending it to counter. And this will return the counts of each num. So if our input is such, then it returns the frequency of each number. So 1 appears 3 times, 3 appears twice, and then 4 and 2 both appear once. Okay, now we want to get the most frequent number. So we can do that by doing counts.values. So from the frequency count, the highest frequency is a 3. Okay, so this will return a 3 for this input. And then the tricky thing is, first of all, counts dot elements is an interesting function. All this does is given this number and its frequency, it returns the number repeated that many times. So let's say that we have this. Then all this does is return 1, 1, 1, because 1 appears 3 times. Then 3 appears twice, so 3, 3. 4 and 2 appear once each, so 4 and 1. That's all it does, or 2 appears once, so 2. Okay? And then once we do that, we can actually return, we no longer need this, we can return a subset, which is, I'll write it down and then we can go over it. Okay, so now remember, k is the highest occurring number, which in this case is 3. Okay, and we're saying from 0 to 3, so range of k is, let's put it here. So range of k is going to be 0, 1, 2, and we're saying we'll take the subset of a from uh, that number to the size of the maximum value count, or maximum frequency count. So this ends up being 0 to the n at a step of k, which is 3, and from 1, 0, 1, and 2. So it becomes like this, 0, 1, and 2, all right? So it becomes, we're getting a subset of 0 to the n with step of 3. So let's build that right now, why don't we? So from 0, and let me add the indexes just so it's a little easier to follow. All right, so we're saying the result is, okay, we're going to return a list of these where the first one is A, going from the first one, 0, okay? And we're going to take every third one. So this one, 1, so 1, 2, 3 is 3. 1, 2, 3 is 3. And maybe we can do that. So we already covered this one. 1, 2, 3 is this. 1, 2, 3 is this. Okay, so the first one is like so. Then this one's done. Okay, oops. And the next one starts from 1 index. So we can do that. 1, 1, 2, 3. So that's that. And then 1, 2, there's nothing there. So just 1 and 3. Okay, and the last one, because we're doing 0, 1, 2, the last one goes from index 2, start is 2, and 1, 2, 3, and 1, 2, we're out of bounds, so 1 and 4. Okay, and then this also works because if there are multiple answers, return any one of them, meaning we also return 3 total. So this one was grouped like so, but the resulting array is size 3. Doing this way, we also return a size 3. So this is an optimal way, and we are able to return this directly. So let's give that a go. Let's run it first. Make sure there's no syntax errors. And submit. And there you have it. This one allows us to run in linear time with linear space. Thanks so much. And once again, let's make that bigger. Once again, this was 2610, convert an array into a 2D array with conditions. Happy coding. See you next time.